Then you will learn what is a built-in function, 10 commonly used built-in functions, syntax of each of the built-in functions, and practical examples of 10 built-in functions. Now let us start with what is built-in function. So when we buy a new house, we get built-in facilities like windows, tiles, ceiling POP and ceiling lights like this. But later on we add house accessories, TV and furniture. But initially we get this kind of built-in facilities within a new house. So same way in Python programming language, there are built-in functions like input and print function. We have already used this function many a times, and we have not defined these functions because these functions are already there within Python programming language. So the definition of built-in function is something like this: a function which is already defined in a programming language with a set of statements to perform some specific task is called built-in functions. So user need not to create this type of function, and one can use them directly in their program or applications. Before going into the detail of what is built-in function, its example and syntax, let me tell you what is an iterable. So here one list is given with 4 values 1, 2, 3, 4, and say for example we have a loop and we take values one by one from this list like this 1, 2, 3, and when it reaches at the end of this particular list, the loop is terminated. So this process of taking values one by one from this list is referred to as a iterating over this particular list. So the definition of iterable is something like this: an iterable is an Python object which allows to iterate over in a for loop, and familiar examples of iterable includes list, tuple, set, string, etc. So any such sequence like this one can be iterated over in a for loop. Now let us look at the 10 commonly used built-in functions, its syntax and its practical examples. And first of all, let us start with built-in function all. So look at this image, and if we ask a question, are all these boys? Definitely the answer to this question is yes, all the persons in this image are boys. Now look at this image again and again ask the same question, are all these boys? The answer is no, it is false, because there is one girl. So all built-in function is used to check whether all the values in an iterable are true or not. Even a single value is false, then it returns false. Now let us look at its practical example and its syntax. Here are some of the Python built-in functions, and now let us look at the built-in function all. Say for example we have a list of true and false stored in a flag list 1, true, 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 true. Then we have a second list with 4 values true, true, false, true, and we want to check if all the items in a list are true. So we have taken this first list over here and we are passing this first list as an argument to the built-in function all. So it will check all the values within a list one by one, and it will check whether all are true or not. So if all the values in a list are true, then it returns true in result. Now let us run it and let us see what is the output. So here we can see that all the values are true, and hence the answer or result is true. Now let us take the second list where we have 1 false and 3 true, and let us run it again, and now we can see that the result is false. The reason is because there is one value which is false. Here is a formal description and syntax of built-in function all. So a function all is used to check whether all items in an iterable object are true or not. Also it is used to check whether all items in a list or a iterable are non-zero or not. It returns true if all items in an iterable object are true, else it returns false. So here the built-in function name all, and then we have to pass iterable as an argument to this function. Here are few more examples. Say for example here these values are given in a list. We have a true and false value, but we can use these built-in functions with all the different data types. So here say for example num underscore list is given and these 4 values are given. We are passing this as an argument, and it will check whether all the values are non-zero or not. If single value is 0, then it returns false, but if all the values are non-zero, then it returns true. Now let us run this and we can see that the answer is true. Now say for example we add some value 0, right? Then we can see that now the answer is false because there is one value which is false. So all values are not true, or all values are not non-zero. Now let us look at the second example. Here we have a tuple. In previous example we had a list. So we are passing this tuple as argument, and within this tuple we have a numeric value, boolean value, string value, and now let us run it and we can see that here we are getting value false. The reason is there is one value whose value is 0. If we make it say example 4.5, then now we can see that the answer is true. The reason is all the values are either true or are non-zero, and hence this all built-in function returns true. And now let us look at the next example where we have a set as a iterable object and all are positive value then, and now let us run. So it is returning true. Same way here we have a dictionary with 3 key value pair. 1 is a key, this is a value, this is a key. In case of dictionary iterable, the all function checks if all the keys are non-zero or true or not. So here we have one key value which is 0, so it should return false. So here we can see that the output is false. But say for example we change it to 2, then now let us run. So it is returning false. And now say for example again if I change this one to 0, it is returning false. Now let us look at the second built-in function any. Just look at this image and just ask this question, is there at least one girl? It is true that there is at least one girl. Now again look at this image and just ask the same question, is there at least one girl? Then we can say that yes, there is one or more girl, right? And now again just ask the same question by looking at this image, is there at least one girl? So now it is false. So the conclusion from these three images is that this any function is used to determine at least single value is true or not. So in first and second the statement is true because there is at least one or more girl, but here we can see that all are boys and hence the statement is false. Same way if all values are false or 0, then any function returns false. Now let us look at its syntax and practical examples. For example, we have a list of true and false values like this stored in a flag underscore list, and we want to check if at least one item in this. Say for example, here we have same list over here, flag underscore list, true, false, true, true, and we are passing this list as an argument to the any function, and it checks if there is at least one value which is true, then this any function returns true in this particular output variable result. Now let us run it, and here we can see that it is true because at least one true value is there. Now here is a formal description of any function. So any function is used to check if at least one item in an iterable object are true or not. It returns true if at least one or more item in an iterable are true. It returns false if all items in an iterable are false. The syntax is like this, the built-in function name any, then here we have to specify the iterable. So here we have a list as an iterable. Now let us look at few more examples. Say for example here we have a number underscore list, and let us run it. So here it is returning true because at least one non-zero value is there, and hence it is. But here in next example let us have all 0 in a list, and now let us run. So we can see that it is done. So if all the values are 0 or all the values are false, then it returns false. So let us run this, and here all the values are false, hence the any function is returning false. Fine. Now let us have one tuple over here. Here we had a list, but now we have a tuple with mix of values, that is integer value, boolean value and string. And now let us run it, and we can see that the result is true because at least there is one true value or one non-zero value. Again let us have a set and let us run it, and again we can see that because there is at least one non-zero value in this particular set, and hence it is returning true. Now let us look at the third built-in function, filter. So in this image adults and children are given, and we are asked to separate out all the adults based on the age of the persons. So we need to check their age. If age is greater than or equal to 18, then the person is an adult. So the filter function is used to separate out data based on such condition. If some condition is given, then we can filter out the data. Now let us look at syntax and the practical example of filter. So say for example we have list variable person underscore ages, and here are the values, and these values are nothing but ages of the person. We want to separate out all the values which are greater than or equal to 18, which represents the adults. Here we have taken the same age values in a person underscore ages variable, and for separating out the values we need to define a filter function like this. So my underscore filter is a function which is receiving this particular list from here filter function. Here the condition is that if age is greater than or equal to 18, it should return true, else it returns false. In filter function we have to specify two things. One is this filter function name, and second the list of data that we want to filter. When the execution reaches over here, it calls this my underscore filter function and passes this filter person underscore age as an argument to this filter function, and it will filter the data that satisfy this particular condition. So here the 18, 24 and 32 will be filtered out or separate outed and will be stored in adult underscore ages, and then here we are printing. Now let us run it and we can see that we are getting all the values which belongs to the adult person. Here is a formal description of a filter function with its syntax. So a filter function returns iterable where the items are filtered through a function, and the syntax is like this: name of the function, then here is a filter function, the first argument, and second function is nothing but iterable like list, set, tuple or a string. Now let us look at Python built-in function zip. In this image we are given two group of people, group 1 and group 2, and we want to make a pair of persons from the group 1 and group 2. So what we do, we take a person from group 1 and first person from group 2, then we take the second person from group 1 and second person from group 2. So this way we go on taking person from each of the group and we make pair. Same way, if we have multiple iterables, 2 or more iterables, we can make pair of data values from 2 or more iterables. Now let us look at the syntax and practical example of zip function. Say for example, here we have tuple 1 and tuple 2 with these values, and here the same tuples are over here, and this is a zip function. We are passing both the iterables, that is tuples, as an argument to this zip function separated by comma. So it will make pair of Ram, Ravi, Jay, Ajay, Amit, Ashok. It will return a paired object or zipped object in result underscore tuple, and here we are printing. Now let us run it. So here we can see that the output is nothing but a pair of Ram, Ravi over here, then Jay, Ajay over here, and Amit and Ashok over here. Here is a formal description of zip function with its syntax. So zip function returns a zip object like result underscore tup, which is an iterable of tuples, because individual values within this particular tuple is nothing but a tuple. So which is an iterable of tuples where items from arguments are paired together. So here we have passed these two arguments, right, and these two arguments are paired. If the past iterators have different lengths, the iterator with the list items decide the length of a new iterator. So here is a name of the built-in function zip, and then we can pass 2 or more iterables separated by comma as argument. So here is a next example to demonstrate the use of zip function. So here we have 3 values within first tuple and 4 values. So we can make a pair of first 3 values, and this is extra. So this will be ignored, means length of the result will be equal to 3. Similar to the previous example, here we are passing both the tuples as argument to zip. After pairing these values from the 2 iterables, it is the zipped object is stored in name underscore zip, and then we are printing. Now let us run it, and we can see that the pairs are created from both the list, but this Vijay is ignored. So here we are ending this video. Thank you very much for watching this video. Have a great time. Now let us look at Python built-in function slice. So here we have a pizza, and there are 7 pieces of this particular pizza. So slice means part of an object. So we can take 1 piece, 2 piece, or we can have as many pieces that we want to make. Objective of slice function is to get part from an iterable object. Now let us look at a typical example and text. So here we have a tuple, name underscore tuple with this particular names, and get only first 3 items from this tuple, then we should use slice function. So here the same tuple is mentioned over here. We are specifying the number of values that we want to get from this particular tuple. So here slice function generates an index, or that will slice this particular tuple. This will return the values within the slice underscore tuple, which will be used for slicing this particular tuple. So here name underscore tuple is returned, and then we use this slice indices over here, and it will return the slice from this. So here it will return the first 3 data items from this tuple. Now let us run it, and we can see that here we are getting first 3 data items from this. So here is a formal description of slice function. A slice function is used to get a slice of elements from collection of elements. We can specify where to start the slicing and where to end. So in this case we are just specifying a value, that is number of elements that we want to slice, so it will start slicing or taking the data items from the first position itself. But also we can specify values, that is start value, end value, and step. Step means at what interval we want to extract, means whether we want to extract the every second element, every third element, or every fourth element. So that is what the meaning of step. Let us look at this example here. In slice function we are using two arguments, the start value and end value. So it will start from the position 2, that is 0, 1 and 2, means it will start from Ashok and it will go up to 2, 3 and 4. So it will extract Ashok, Vijay and Amit. Now let us run it and we can see that Ashok, Vijay, Amit are sliced from this particular tuple. Here is a next example where we are specifying three arguments, start value, end value, and this is a step 3, means every third value should be sliced from this particular tuple. So every third value means it starts from 0, Ravi, then third value is Vijay, again from this third value is Raj. So Ravi, Vijay and Raj should be sliced from this particular tuple, and here we are printing that slice values. So here we can see that Ravi, then Vijay and then Raj is sliced. Now let us look at the next built-in function, sorted. In this image we can see that people are standing in queue, but they are not in ascending order of their heights or descending order of heights. But in this image all the people are standing in ascending order of their height. If we consider from this right hand side, sorted function is used to arrange the data items in ascending order or a descending order. Now let us look at the formal description, its practical example. Here we have a list of the alphabets which are arranged randomly and we want to arrange them in ascending order. So here same array is taken and we are storing that array of characters in a tuple, and we are passing these letters tuple as argument to the sorted built-in function. So it will arrange all the items in ascending order if we are not specifying any order over here. So sorted letters are stored in the sorted underscore letters and we are printing. Now let us run it, and here we can see that all the letters are arranged in ascending order. Here is a formal description and syntax of sorted built-in function. So the sorted function returns a sorted list of the specified iterable object, and we can specify the ascending or descending order. So here we are using only one argument, but it is possible to have two arguments over here. So first one is the iterable to be sorted, and second is nothing but whether we want to arrange in ascending or descending. So this reverse takes the true or false value. So value, if do not specify this reverse value, then it is false. But if we specify reverse is equal to true, then it arranges the data in descending order. If the data within the iterable are string, then they are arranged alphabetically, and if this iterable contains numeric value, then that numeric values are sorted numerically. Now let us look at this example. Num underscore list is equal to 5 numeric values are there. We are passing this list as argument to the sorted function, and now let us run it. We can see that all the data items are sorted in ascending order. Here is a next example where we have same list, but now here in sorted function we are specifying the reverse is equal to true, means we want to arrange these data items in descending order. Now let us run it, and we can see that the values are now arranged in descending order. Now let us look at the next built-in function, power. So here we can see that 2 is a base, 3 is an exponent, and if we consider x as a base and y as an exponent, then it will be x raised to the power y. So power function is used to find x to the power y like this. Its syntax is power x comma y, means finds power of x to the power y. Now let's look at its syntax and practical example. So here we have a power function. We want to find say 2 raised to 3, then directly just specify the two arguments and we can see that the answer is nothing but 2 raised to 5. And here we have a say 10 raised to 3, then run it and we can see that 1000. Now say for example the same example, but here we are assigning 10 and 3 to x and y, and we can pass these variables x and y as a argument to the power built-in function, and it will return power of x raised to y, that is 10 raised to 3 in results. And now let us print it. So we can see that we are getting some. If we change this, say for example 4, then again let us run. So it is giving 10,000. If we change this to say 3 again, so 3 raised to 4 is 81. Now let us learn Python built-in function round. So here the original numbers are given and these are the rounded numbers, and we want to round these numbers up to 2 decimal places. So 10.45, and next after 5 here third digit after the decimal is 9. So here round up operation is given. Round up operation means if third number is greater than or equal to 5, then 1 is added to the last digit within the precision required. So that is why this 5 plus 1 is 6. That is why the 10.46. Here in this particular number, as we want precision up to 2 decimals, so we have to look at the third digit, and this third digit is less than 5, and hence we have to take the same value which is over here, that is 32. So 32 is directly, so this is referred to as a round down operation. And here let us look at this last value, and here the 191.76, and this value is 5, means it is greater than or equal to 5, so 1 is added, so 1 is added to 6, so it will become 7, so 191.77, and this is a round up operation. Say for example we don't want any decimal digits after the decimal point, then we have to look at this first digit after the decimal point. So this number is less than 5, and hence we need to take this value as it is, that is 6, and this is referred to as a round down, because 6.465 is larger than 6, and hence the operation is referred to as a round down operation. But here in this last value we have 6.7, and this 7 digit 7 is greater than or equal to 5, hence we have to add 1 to this particular value. So 6 plus 1 is 7. So here this 7 is larger than 6.723, and hence this operation is referred to as a round up. So round function is used for rounding of the numbers as per the rules that we have discussed right now. Now let us look at the practical examples and its syntax. So here we have a round built-in function, and say this floating point number with 2 decimal places. So it should extract this particular part, that is 4.78, but as this third digit is 6, which is greater than or equal to 5, and hence 1 should be added to this number, that is 8 will become 9. So result should be 4.79. Now let us run it, and we can see that the result is 4.9. Here is a formal description and syntax of built-in function round. So a round function returns a floating point number, that is rounded version of specified number, as a first argument, with the specified number of decimals, that is the second argument. And here is a syntax, name of the function, that is round, then the first number to be rounded, and the digit decide the number of decimal to use when rounding the number. And if we don't specify this particular, then default value is 0. So here is the example where we don't have these digits, and hence it will perform the rounding and it will ignore the digits after this. But here it will look at this particular digit. If this digit is greater than or equal to 5, then it will add 1 to this 4. That is, now let us run it, and we can see that 4 becomes 5. So this is a round up operation. Here we have the similar number, but here the digit is 3, which is less than 5, and hence it will take this same number, and now let us run it, and we can see that we are getting 4. So this 4 is less than 4.38653, which is smaller, and this is round down. Now let us look at the next built-in function ID. So we know that every person has their home address. Similarly, the variables and objects in a Python have their memory address. So ID function is used to find address of an object. Now let us look at its syntax and practical example. Say for example we have a variable n is equal to 5, and we want to find memory address of n. Then we have to pass n as an argument to the built-in function ID. So address will be written over here in an address variable, and here we are printing. Now let us run it, and here we can see that address of variable n is this one. This is a memory address of variable n. Here is a formal description of ID functions and its syntax. The ID function returns a unique ID for the specified object, and all object in a Python has its own unique ID. So here ID means the memory address. The ID is assigned to the object when it is created, and ID will be different for each time you run the program. So every time when we run this particular piece of code, then n will have different value. Here is one more example to demonstrate the use of built-in function ID. So we have a list of fruits, and we are passing this fruits list as argument to ID, so it should return address of fruits. Now let us run it, and we can see that address of object fruit is this one. Now let us look at the built-in function sum. So here we can see that in this image there are 4 different groups of apples. In first group we have 3 apples, here 2 apples, here 1 apple, and then 6 apples are there. Suppose we have to find total number of apples in this particular image, then what we do, we take 3 plus 2 plus 1 plus 6, and that is how we do sum of apples. Built-in function sum is used to add data items in an iterable object. Let us look at the practical example. Here we have a number list and 3, 2, 1, 6 are the values stored in this number list, and this 3, 2, 1, 6 represents the number of apples 3, 2, 1 and 6. And now here we have the same list over here, and we are specifying this num list as argument to the sum built-in function. And now let us see, we can see that the answer is 12 because total number of apples are 12. Here is a formal description of built-in function sum. So sum function returns sum of all items in an iterable like list, tuple, set, and here is a syntax sum with 2 arguments, that is iterable and start. Here we had a 1 argument only, but we can specify the second argument which is optional, and this is nothing but a value that is added to the return value. This value should be specified when we have a situation like, say for example, we have already 5 apples and now we want to add these more apples with already existing apples. So what we do, we start adding like this 5 plus 3 plus 2 plus 1 plus 6. So this same situation can be simulated in our program like this. We specify this number list over here, that is number list, and then we start with, as we have 5 apples over here, here we have value 5 over here, so it will start adding from 5. So 5 plus 3 plus 2 plus 1 plus 6 will be equal to 17. So now let us run it and we can see that we are getting the answer 17. So this is all about 10 commonly used Python built-in functions. We already have learned following built-in functions like ABS, type, range, enumerate, and in next video you will learn about Python functions in detail with implementation of various problems. So here we are ending this video. Thank you very much for watching this video. Have a great time.